Dear distinguished guests, welcome to the Marine Engine Technology 7 webinar series event. Today we'll welcome dear Christopher Fee, the General Manager of Oldendorff Carriers. He will present you the biodiesel utilization as fuel on marine diesel engines. I believe he will also refer to environmental and sustainability aspects of using biodiesels. Mr. Fee, please, you may start your presentation.
Thank you very much. Good day, everybody. My name is Christopher Fee. I work at Oldendorff Carriers. We're a ship owner and operator based with headquarters in the small town of Lübeck in northern Germany. I am the General Manager for Environment and Sustainability. I've been working for the company for about 8 years, previously working for other ship owners and ship managers in the Hamburg area. I would first like to thank Professor Nuran for inviting Oldendorff to deliver today's presentation to Dokuz Eylül University. Thank you very much for everyone's time today to participate. A little bit about our company before I jump into the topic of the presentation, which is our experience with biofuels. So our company was established in 1921 in Germany. Last year we celebrated our centenary, and unfortunately we were not able to celebrate like we wanted to due to the corona pandemic. But hopefully we can celebrate this year if all goes to plan. As mentioned, ship owner and dry bulk operator. We have in the past operated some container vessels and tankers, but that was a long time ago. These days, we are purely focused in the dry bulk sector and transshipment and marine salvage. We are privately held and family-owned company, so we're not listed on any stock exchange. We've come a long way in our 101-year history. As you can see from this collage of photos, this is what we've achieved in our history. This is what we look like today. At any point in time, we're owning and operating more than 700 vessels. So I would say 1 in every 5 of the vessels that we operate are physically owned by Oldendorff or on bareboat in. And the rest are chartered in. So our fleet fluctuates almost on a day-to-day basis. We transport more than 380 million tons of dry cargo per year. This is also strengthened and supported by our 10 transshipment sites around the world. The first transshipment site or project that we established was actually in Turkey, in the Bay of Iskenderun, and I have a few slides to illustrate and explain that operation later on in the presentation. We make more than 15,000 port calls each year across 120 different countries. We are strengthened by the expertise of more than 4,500 employees worldwide. We have a global reach. We have 20 offices around the world, covering all the major time zones, and offices where it's strategically important for us to have a physical presence, particularly if there's a demand from the client side to do so. We're proud to be a multicultural company, so we have colleagues from more than 60 different nationalities, and our typical annual turnover is $5 billion. This is a snapshot of our offices around the world. So as mentioned, we are covering all the major time zones from Vancouver and the west coast of Canada all the way to Tokyo and Melbourne. And you can see our office there in Iskenderun, also on the map. That's where our transshipment operation is located. And our headquarters is in Lübeck. And our major commercial offices are in Hamburg and Singapore and to a larger extent also Stamford and London. We are lucky to be able to say that we've achieved solid performance year on year throughout our history. We continuously deliver positive financial results and excellent operational performance. Having a strong financial position and low leverage, in other words, with long debt maturities and fixed interest rates, this puts us on a strong financial footing. Our current investment of approximately $3 billion in environmentally friendly vessels, primarily funded from our own operational cash flow. Our significant net worth gives confidence to our clients who entrust us with long-term industrial contracts of affreightment, COAs, and as well as repeat spot business. We are proud to say that we fulfilled 100% of our contracts, charters, and financial obligations throughout our 101-year history. This is a fleet profile snapshot as of the 15th of February. So already these numbers have changed, but because as I mentioned, the operating fleet fluctuates almost on a day-to-day basis as vessels are chartered in and chartered out. So as of 15th of February, we're operating 703 ships with a total deadweight of 63.3 million deadweight tons. And we tend to operate young vessels with superior energy efficiency credentials. So the average age of the fleet is only 6 years old. So 155 of these vessels are actually owned or bareboated in by us. The rest of 530 ships are time chartered. The vessels that we have in our own fleet, their energy efficiency credentials are primarily achieved through the use of very energy efficient engines. So our larger vessels, Newcastle Maxes, 206,000 to 208,000 deadweight, these primarily are fitted with the latest Mark 9 G-type engines from MAN. These are ultra long stroke. So this allows for the ultra long stroke results in lower engine speed and a lower RPM, which in turn allows the use of a larger, more efficient propeller. The larger propeller is significantly more efficient in terms of propulsion, which reduces fuel consumption and resultingly also reduction in carbon dioxide emissions. The vessels are also equipped with auxiliary engine economizers designed to recapture waste heat from the auxiliary engines. And on the right-hand side, you'll see these vessels are also equipped with Becker Mewis ducts and rudder bulbs. These are power-saving devices which provide fuel savings and reduction of greenhouse gas emissions. The Mewis duct itself enhances the flow of water to the propeller to increase the thrust, and the rudder bulb is an additional power-saving device which changes the hub vortex to streamline the flow behind the propeller. These two eco features combined produce a fuel savings of between 5 to 8%. This is significantly influenced by the condition of the hull. So if there's a lot of hull fouling can impact the effectiveness of these two eco features quite significantly. To give you an illustration of the types of vessels that we operate, so the smallest vessels in our fleet are handy-size, open-hatch box ships. These are actually classified as general cargo ships, not bulk carriers, the ones on the screen here. And we also have Ultramaxes, then Kamsarmaxes, baby capes, which is a segment that we are particularly strong in. I believe we have the largest baby cape fleet in the world. This allows vessels with relatively shallow draft, but a large cargo intake to enter shallow ports. So these vessels are somewhere between a post-Panamax and a Newcastle-Max in their design. And then the largest vessels in our fleet are the Newcastle Maxes. So we worked very closely with Hyundai and Maersk to develop the most economical Newcastle Max forms. Again, these are using the G-type engine from MAN and are fitted with newest ducts. Just going back to the baby capes, so what's interesting to note is that we have a mixture of fixed and floating price index period charters, owned vessels, and trip chartered vessels. So Oldendorff has recently invested in the baby cape segment with a purchase of 15 modern vessels to strengthen the baby cape fleet. A snapshot of the type of cargoes that we typically transport. So I would say the three at the top there, iron ore, coal. So this would be metallurgical and thermal coal, grains and agri products. They account for about 85% of the volume of cargo that we ship each year. But and the iron ore and the coal is typically transported in the larger vessels, the Newcastle Maxes. We ship bauxite for the aluminium industry, aggregates, fertilizers for agriculture, also some semi-finished steel products, piping. We transport wind turbines to support the energy transition. So those are transported on our smaller vessels, so handies, ultras. They're transporting the wind turbines around the world, and also some forestry products. Our transshipment division that we launched in 2002. Oh, it's already 20 years old. So yeah, our logistics solution results in substantial freight savings for our clients. Our transshipment of cargoes from or onto larger vessels provides lower freight rate per ton on long-haul trades. We can arrange both ocean transportation as well as transshipment in a safe, cost-effective, and environmentally friendly manner. And we assume full responsibility for the entire package. So our clients can rest assured that their cargo can get from A to B efficiently and reliably. We have dedicated a team of material handling experts, naval architects, engineers, and captains to manage our projects. Most importantly, we develop tailor-made solutions for our industrial clients. The first project started in Turkey in 2002, and we already now have 10 transshipment projects in operation around the world, including in the Arabian Gulf, Trinidad. We had in Guyana for many years, Andaman Islands, Vietnam, and where else? I think that's about it, actually. And we have 1,100 employees in this particular division. So far, we've invested about $600 million in this particular segment, and overall, we've transported 2 million tons of cargo we've transshipped since the first operation came online in 2002. And the annual volume for transshipping is about 40 million tons. Just going back to to this slide a little bit about our clients. So our cargo clients include raw material producers, agricultural traders, importers, exporters, steel mills, power companies, and also other industrial end users. Currently, this is where we operate our transshipment. So in the Bay of Iskenderun, we are importing coal for a thermal power station. That's been going since 2002, and we are typically importing 3.5 million tons per year. And this cargo is typically coming in on Capesizes or Newcastle Max vessels and being transloaded or transshipped into barges, which can then go into the draft restricted port. But our other transshipment operations around the world, we are transshipping iron ore, bauxite, and coal. This is a bit of an illustration of our operation in Turkey. We're very proud of this. We have a very strong team down there. They're doing a fantastic job. Every year, they are continuously improving the operation, increasing the efficiency, and we can comfortably say this is the most efficient transshipment operation in the world. So the cargo here is coal coming from Colombia and South Africa predominantly. And we have a transshipment platform called the Isken. It's typically located 2 miles off the coast in deep water. It is the world's largest and most productive floating coal transshipment terminal. And we have 2 barges, 2 tugs, and 1 crew boat, and about 96 employees in this operation. And this is how it looks. So the Cape-sized vessels come alongside the Isken, and these 3 Liebherr MPG cranes discharge the Cape and transship it into a barge, which is these are pusher barges. So you can see on the bottom right, these are pushed to shore by our own tugs. The Iskolden is the name of the Turkish affiliate that operates the Isken. The Isken itself is an innovative platform that can transship up to 50,000 metric tons per day. It was ordered from Poland and started operation in Turkey in November 2002. The barges are also self-unloading, so when they come alongside at the power station, they discharge themselves. The client runs a 1,300 megawatt power station nearby, and you can see it in the distance on the picture at the top. So when the coal is transferred at the platform via hoppers and conveyor belts to a central barge loading chute where the barges are loaded between the transshippers' twin hulls. Tugs then push the barges to a jetty at the power station where they are self-unload directly into a receiving hopper at 2,500 tons per hour in an economically friendly manner. This system essentially overcomes the 6-meter draft restriction at the jetty in the most economical way. This saves owners and the power station an enormous cost and resources that would have been required to build and operate a Cape-sized port. A recent division that we established at Oldendorff, probably about 3 years ago, was a marine salvage division. Our transloaders have performed several major ship-to-ship salvage operations. 12 of our transloaders are fitted with side-mounted cranes that are capable of unloading up to Cape-sized bulk carriers, making our vessels uniquely suitable for bulk salvage operations. And on the screen here are 2 examples of marine salvage operations that we have successfully carried out since establishing this division 3 years ago. 3 of our transloaders are normally located in the Arabian Gulf area, while the other 9 vessels are trading worldwide. So we're never far away from a salvage operation. And now that I've spoken a little bit about our company, I would like to share with the audience some information about the experience we've gained. Yes, sure.
Sorry for interrupting. Can you please turn up your volume a little bit more so we can hear more clearly?
Is that better? Is that better?
Did you?
Can you hear me better now?
Yeah. Can you turn up your volume?
Yes, I have. I have
Okay.
turned up my volume. It's as loud as it can be.
Thank you.
You're welcome.
Thank you very much.
I'll just speak a bit louder.
Please. Sorry for
as long as you don't think I'm shouting at you.
No. We will never think about that. Thanks very much. You can continue, please.
Thank you. So the topic at hand is biofuels. Since April last year, or actually probably already January last year, we started looking into experimenting with biofuels on some of our vessels. In last year, we began conducting trials with the 2nd generation biofuel containing used cooking oil, also known as UCO or UCO biodiesel, as its feedstock. So when we say 2nd generation, this is the biofuel is coming from a feedstock that is not competing with agriculture. So 1st generation biofuels are somewhat controversial, and we wanted to stay clear of that. But 2nd generation biofuels are much more sustainable and less controversial. This first trial we did was in collaboration with the Marine Ports Authority of Singapore. One of our major clients, BHP, it's a mining company based in Australia. Good Fuels is the Dutch company that provided the biofuel, and Maritime Singapore was also a partner in this trial. And as you can see here, this is the Kira Oldendorff. She's a Eco Kamsarmax, which was built in 2020, and she's being bunkered with the biofuel product at Singapore Anchorage. So what makes biofuels interesting to us and our clients? Well, these are somewhat low-hanging fruits in terms of reducing or improving energy efficiency and reducing emissions. So no capital expenditure is required. Of course, during this trial, we ordered some spare parts just for engines and filters and separators, etc., simply as a precaution. But in the end, we didn't actually have to use them. So the biofuels themselves don't really require any capital expenditure. So it's something that can be implemented immediately. You can use it as a drop-in fuel or in its pure form. It can be used in any diesel engine when mixed with conventional diesel. It's compatible with tanks and fuel delivery systems on our ships. When used in its pure form, some maintenance and performance problems may occur during wintertime utilization, as the fuel can become viscous at lower temperatures, but depends largely on the feedstock used in the biofuel itself. But as biofuels are functionally equivalent to petroleum-based fuels, they can generally utilize existing infrastructure such as the bunker barges, storage silos, etc. So no modifications are required in the existing infrastructure. Although the bunker suppliers may require that the lines are flushed out before and after biofuel bunkering with low sulfur marine gas oil, just for the sake of good order. And it offers our clients a relatively simple and immediate way to help them reduce emissions across their value chain and improve their sustainability credentials and obtain some positive public relations. The if you compare this to other solutions to improve energy efficiency, such as fitting Flettner rotors or running on, converting the vessel to run on methanol or LNG or whatever have you. These are massive projects that require a lot of capex and taking the vessel off hire for many weeks, possibly months. So biofuels is something that can be done today, and that's what's attractive about biofuels to us and some of our clients. So what are biofuels? Well, they are fuels that are produced from biomass, such as plants, or from agricultural, commercial, domestic, and or industrial wastes, if the waste has a biological origin. They're similar in composition to conventional diesel, which is why they can be used as a drop-in fuel or as a pure biodiesel product in existing infrastructure, engines and bunker barges, etc. But it's important to point out that not all biofuels are created equally. So as briefly mentioned, there's first generation biofuels which are made from food crops such as corn, soybean, or palm oil. As you can imagine, these are controversial due to land use issues. However, most of the biofuels component that's in automotive fuels, so when you go to the petrol station and fill up your car, particularly here in the EU, that is first generation biofuels. So it is very controversial because you're competing with agriculture. Second generation biofuels is something that we are only testing at the moment because it's available, albeit in limited quantities and only in selective ports. But at least we're not competing with land agriculture. It's made from biomass or agricultural residues and wastes. The biofuel first biofuel trial we conducted was on was a biofuel with a feedstock of used cooking oil. Then there's third generation biofuels, which we're already looking into. These are typically algae-based biofuels, so algae grown in the oceans and or in algae farms. There's a really inspiring operation in Hawaii, and they are expanding that to California, where they are trying to produce algae-based biofuels in large quantities. It's still pretty much in the intermediate research state, and the quantities that are available on the market are very, very limited and hugely expensive. You're looking at, and I'm going to shock you here, between $3,500 and $20,000 per ton. So prohibitively expensive for even conducting a trial. But like any type of alternative fuel, the prices will come down significantly as production techniques improve, production processes become more efficient, and demand for the product increases. Then there's even fourth generation biofuels that are being discussed, and these are synthetic biofuels, but this is very much in the early research state, so nothing really to discuss there. As mentioned, the biofuel trials we've conducted, and we've done 2 so far, these have been blended products, so blended with conventional fuel, either very low sulfur fuel oil or marine gas oil, or low sulfur marine gas oil, and second generation biofuel. The International Energy Agency want biofuel to meet more than 1/4 of world demand for transportation fuels by 2050. So there's a clear signal from regulators and influential international agencies to expand and support the biofuel production and supporting infrastructure. So Oldendorff take safety extremely seriously, and before we conducted this biofuel trial, we drafted a comprehensive risk assessment, and I put it just on the screen here for you. You don't have to read it, but it just gives you an impression of all the different considerations that we had to keep in mind before simply bunkering biofuel and feeding it through our fuel conditioning module and into the engine. And because we wanted to carry out in situ measurements of the actual emissions instead of simply just doing a calculation based on the chemical composition of the fuel, we also created an emission sampling protocol prior to the trial. As there was always a chance that the actual emissions exceed the MARPL Annex 6, either due to higher than expected carbon dioxide emissions, or which was more concerning to us was increased NOx emissions, we applied for approval from Flag State and our hull and machinery underwriters, just for the case that the emissions exceeded MARPL Annex 6, but we are happy to report they didn't. But this is all for good order's sake. We also contacted the engine makers. So the vast majority of our vessels are equipped with main engines from MAN, and they already had a guidance for owners that were wanting to carry out trials on biofuels with 2- and 4-stroke engines. So we followed their guidance at all times. Additionally, we contracted a laboratory to carry out a sample analysis prior to use. The second, it was a 200 for the first biofuel trial. We had a 200 metric ton mix of 50% biofuel and 50% gas oil, and the sample was submitted for testing the stability. What's interesting to note at the bottom right is they also test the copper, or they have certain advice for in respect to copper corrosion and bacteria. So biofuels, one thing that really needs to be kept in mind is that it has a shelf life of about 6 months. So you can't just order it, store it on board indefinitely, and then use it in a year's time, because it will it'll go off and create almost like a sludge and is just simply unusable. For the onboard emission monitoring, we invested in not just one but 2 portable flue gas emission analyzers. These are industrial quality, very expensive. I think the 2 of these together cost us about 17,000 euros, but they're super good quality, and we consider it an investment because we want to carry out further biofuel trials, and we will use these for subsequent trials. So this adds additional value to our clients who are interested to have the emission savings verified. So the planning and coordination with the flag, insurers, machinery makers, and class took about 4 to 6 weeks. So this is something that needs to always be considered. It's not just a case of, okay, we're going to bunker biofuels for our client, and there is a significant amount of planning that is required. Piping, service, and settling tanks were cleaned and flushed with gas oil to eliminate heavy fuel oil residues. Spare parts were ordered on the recommendation of the engine maker and also after internal consultation with our in-house experts. Additional spares were supplied for the auxiliary engine, purifiers, and the auto filter. The low sulfur marine gas oil tank was prepared by cleaning with chemicals. Prior to bunkering the biofuel, we also used an additive. A pre-inspection of the main engine was arranged prior to bunkering the biofuel. So we had representatives or service engineers from MAN come on board. The chief engineer was asked to arrange a scrape down analysis every second day to monitor the iron content. In addition to that, a low BN oil was used on the main engine when running on the biofuel. One generator, so we typically have 3 generators or auxiliary engines on board our bulk carriers and general cargo ships, and one generator was always on standby on gas oil from emergency supply in case issues with the other 2 generators running on biofuel were occurred, which they didn't. Separated heated tanks were used for storage, and supplies guidance was strictly followed at all times. And the biofuel was kept stored and heated at about 30 degrees centigrade and was purified at 50 degrees centigrade before use. And for us, it's always important to get feedback from our crew. And in this case, from the chief engineer, we asked him to provide an unbiased, completely honest post-trial feedback. And this was his responses to our main questions. So was it easy to handle? His response was, the biofuel by its characteristic and behavior is very similar to gas oil and diesel oil. The vessel was sailing in tropical waters during the testing period. Therefore, we didn't face any problems with storage and transfer or sludge creation due to low temperatures. The engines and pumps were working well without any troubles. We then went to ask whether did they experience any difficulties. He said that soon after the commencement of the biofuel use, they cleaned the fuel automatic filters once again. This situation, considered as normal when remained high fuel residues, were washed out from the HFO service tank. Later on, everything was okay. And when asked if he had any general comments, his response was, in order to get a more clear picture of biofuel's effectiveness and its influence on ships' machineries, the test should be repeated with a longer time period and at different temperature zones. Based on gained experience, we believe that the ship's crew is ready to do it again. So this shows a keen interest in the crew to experiment or trial different biofuels from various suppliers and different biofuel content ratio, and that it was a stress that we, in order to really get empirical data and understand the potential long-term impacts on the main engine and machinery and fuel, the supporting infrastructure on board, for supporting machinery on board, then the trial should be conducted over a longer period with a larger stem of biofuel. And they didn't have any concerns either. So the trial ran without complications, and the precautionary spare parts we ordered were not needed in the end. So this all goes down to precise planning and close communication. So this highlights how important it is to have shore and ship-based colleagues working closely together on these kind of projects. To add credibility to the trial and as our gift to the to industry and to science, we asked MIT, Massachusetts Institute of Technology in Cambridge, Massachusetts in the US, to carry out a study. So they actually helped us develop the emission sampling protocol. So Oldendorff signed a multi-year research agreement with MIT back in November 2019. So in our quest to decarbonize our fleet, we worked with CBA and its campus collaborators, including their C grant program to investigate disruptive technologies, disruptive improvements in ship design and propulsion, with the view to achieve the IMO's 2030 and 2050 greenhouse gas reduction requirements, as well as the targets set by the EU. The initial emphasis has been directed at improving hydrodynamic efficiency, which builds on CBA's what they've been doing with the aerospace and automotive industries. So this looks beyond traditional naval architecture, but to a deeper integration of form and function. Research areas include morphing structures, hydrodynamic cloaking, moving boundary layers, and alternative energy sources. So they analyzed the MIT's scientists and researchers. They analyzed the results and of this biofuels trial that we did in between April and May last year on the Kira Oldendorff, and submitted a paper to the Royal Society of Chemistry, which was peer reviewed and published online a month and a half ago, I believe. And the conclusions of the study was that there's only really a marginal tank to wake carbon dioxide reduction when compared to operating on low sulfur marine gas oils. So it's only about 1% saving in CO2 from a tank to wake basis. So what's coming out of the stack, out of the funnel. And this is across all 5 engine operating modes that we ran the vessel at when taking these emission samples. However, there's about a 3% reduction in nitrous oxides. The sulfur dioxide emissions were down about 50%, but that's really down to the composition of the fuel itself. However, if you look at the well-to-wake carbon dioxide reductions, you could actually, this particular trial achieved a 40% reduction in carbon dioxide emissions. This is based on the 50-50, so 50% biofuel, 50% low sulfur marine gas oil. So if we'd use the 100% product, so B100 product, we estimate approximately 80% reduction in CO2 emissions on a well-to-wake basis. So from the entire life cycle analysis assessment of the biofuel, we would have achieved an 80% reduction in CO2 emissions. So this emphasizes the importance that the IMO, which is our industry's regulator, should look to adopting well-to-wake or life cycle assessment methodology for all fuels, because currently all the carbon factors that the IMO use are purely tank-to-wake based. Now, the regulatory landscape that the shipping industry is facing is very challenging, and likely to these targets are likely to be strengthened in the years ahead. So currently, we are our industry needs to achieve a 40% carbon dioxide reduction by 2030, a 70% carbon dioxide reduction by 2050, and an overall reduction in greenhouse gases by 50% by 2050. These are compared to 2008 levels under the IMO's under the IMO regime. But we have to always remember that we are trading in the EU bloc as well, many of our vessels. So the EU tends to be more stringent and have much more ambitious carbon reduction targets. So they have committed not just the shipping industry, but the entire EU bloc to a 55% greenhouse gas reduction by 2030 compared to 1990 levels. This confuses things even more because the EU is using a 1990 base level and the IMO is using a 2008 level. Following the COP26 meeting in Glasgow in November last year, there's a lot of pressure on the IMO to increase their ambition to align with the Paris Agreement. So there is a good chance that they, what you see on the left-hand side is increased to zero emission or net zero emissions by 2050. There is a lot of discussion in Brussels at the moment in how to regulate shipping. And what we know so far is that there are two key proposals that are under discussion. One is to bring the international shipping into the existing EU emission trading scheme. This will apply to all vessels of 5,000 gross tons and above, so it'll impact basically all our ships. And the scope of this, the emissions regulation will be all emissions generated from voyages that we conduct between EEA ports, so not just EU, but also the entire European Economic Area, so that includes also Norway and Iceland, and plus 50% of emissions generated from voyages that are departing an EU port to a non-EU port, and 50% of emissions generated from voyages from a non-EU port to an EU port. And this is likely to come into force from 1st of January next year. And it's going to be in stages. So not all eligible emissions will be taxed from 1st of January, but they plan to tax 20% of eligible emissions in 2023, 45% in 2024, gradually up to 100% of eligible emissions by 2026. And there's already pressure by various groups in Brussels to bring that forward by a year. So 100% emissions by 2025. And who is responsible? Who will bear the immediate cost? It'll be ship owners. So there's currently clauses for charter parties that are being drawn up by BIMCO for that ship owners and charterers can use to factor into the carbon pricing into contracts. Then, in parallel to all this discussion on taxing emissions, there's also the Fuel EU Maritime, applies also to all vessels 5,000 gross tons and above. And this is a proposal to reduce the greenhouse gas intensity of onboard energy used during all voyages between ports in the EEA, at berth and in the EEA. So it will require the greenhouse gas intensity improvements to from 2025 and increase every 5 years until 2050. So this is to encourage the uptake of alternative sustainable fuels. And they aiming for a target of 75% energy efficiency improvement by 2050. And again, the responsibility will lie on the ship owners. In parallel to complying with mandatory requirements and targets set by the regulators, there are also some public-private initiatives that are gaining a lot of traction. One in particular is the Global Maritime Forums initiatives, and they have developed 3 different sub-initiatives, each targeted at various stakeholders in the maritime chain. So the Sea Cargo Charter was developed a year and a half ago, and this is they're trying to get major charterers to sign up to and commit to a decarbonization trajectory. Then there, so for example, there's companies like ADM, Cargill, Trafigura, Tata Steel, all signatories to the Sea Cargo Charter. Then they've also targeted the lenders, so the banks that are financing the purchase of ships. So this is known as the Poseidon Principles, and it's essentially the same thing as the Sea Cargo Charter, except they use a different carbon intensity indicator. They use the AER, while the Sea Cargo Charter uses the EEOI, and we'll discuss that in a minute. And quite recently, as recent as December last year, the Poseidon Principles for the marine insurance sector were also introduced. So this is targeting them, the hull and machinery underwriters. So they will also, signatories such as GARD will have committed to a decarbonization trajectory. So the banks, the charterers, the marine insurers all want to improve their sustainability credentials and green up their portfolios. And these are the initiatives they've signed up to help them achieve that. 2023 is a critical year for shipping. So it seems like everything is happening on the 1st of January 2023. So we've got the IMO are introducing their A to E energy efficiency rating system. This is essentially the fridge sticker for ships. The IMO also introducing this technical energy efficiency measure known as the EEXI, so the Energy Efficiency Existing Ship Index. It'll be the first year for the EU's emission trading scheme for international shipping. It's also the first year for reporting to the EU's Corporate Sustainability Reporting Directive. So this will mean that large companies, not just public listed companies, but large companies like ourselves, even that are privately held, that are above a certain revenue threshold and employ, I think, more than 500 employees, we will be subjected to this requirement, this directive. So we will have to report on our environment, social, and governance metrics. And as mentioned in the previous slide, the EU's Fuel EU Maritime will also come into force. But actually, the correction to that is looking like it's going to be introduced in from 1st of January 2025. But even so, we will have to prepare for it. The EEXI, the technical measure, this will mean that unless there's going to be major modifications made on older tonnage, most ship owners will fit a so-called engine power limiter, which is essentially similar to a governor on an engine, or putting a brick under your accelerator, and there'll be a seal on the main engine. It can be overwritten in emergency situations, but there'll be a lot of red tape to get that seal resealed. So you have to get class and flag, or class on board representing flag to reseal it, and there'll be a lot of paperwork to fill out. So your justification for exceeding the EEXI will have to be very, very strong. For older tonnage with mechanically controlled engines, it will be simply one of these, almost like a screw. But for older tonnage with or even younger tonnage that is not meeting the EEXI, there will be a small computer device that will have to be integrated. And the EEXI is essentially calculating the grams of carbon dioxide per deadweight nautical mile. And simply put, it's environmental cost versus the benefit to society. So how much emissions you are generating versus how much transport work the vessel is performing. Then there's the carbon intensity indicators. This is the fridge sticker for the ships. So this comes on top of the technical measure that I mentioned in the previous slide. And just going back a couple of points here is that for the EEXI, BIMCO has released an EEXI clause that ship owners and charterers can integrate into contracts. RightShip are unlikely to give improved GHG ratings based on fitting an EPL. It will cause some ships to slow down, and impact on our fleet appears minimal relative to the average trading speed. So the carbon intensity indicators, these are dynamic operational requirements to improve the energy efficiency of ships. One is required by the IMO under the mandatory requirements. The other is something that is introduced by the Sea Cargo Charter. So we'll focus on the CII that is being implemented by the IMO. It's a ratio of carbon emitted to transport work, measured on a voyage-by-voyage basis or annually. The carbon intensity indicator is to be established for each ship and should be measured each voyage and for the full year. The IMO requires an annual efficiency ratio based on energy efficiency rating of A to E. So many of you might be familiar with the RightShip's A to G ratings scheme. Well, this is similar, but just on an A to E letter grade system. If a vessel is rated D for 3 consecutive years or rated E for 1 year, it will require a corrective action plan outlining how the required index would be achieved. So likely how we will get the vessel back up to a C rating. So that will either mean slowing down even more or running on, starting to run on biofuels for part of the voyage, or retrofitting energy saving devices. This is coming into force on 1st of January 2023, and the annual reporting will be completed by 31st of December, and the first rating will be given sometime, we imagine, in the first quarter of 2024. So the way we understand it is that the Ships Classification Society, that is acting on behalf of the flag state, will issue a certificate within the first 3 months after the reporting period, stating how stating the letter grade of the respective vessel, whether it's A, B, C, D, and E, as well as the vessel's annual efficiency ratio. Again, BIMCO is also working on a CII clause that's much more complex. So some routes are more efficient than others, and one voyage can essentially destroy a year. So this is something that's going to be very challenging to implement into contracts, into charter parties. These are the 2 competing carbon intensity indicators compared side by side. So on the left-hand side, you have the annual efficiency ratio. This is adopted by the IMO, as mentioned in the previous slide, as the official carbon intensity indicator for their A to E ranking system. It's also adopted by the Poseidon principles by the banks and the Poseidon principles for the marine insurers. It's similar to the EEOI, the Energy Efficiency Operational Indicator, which is on the right-hand side, except that it uses deadweight as a proxy for cargo intake, and it considers the entire distance in the denominator, while the Energy Efficiency Operational Indicator only considers the laden distance. It's calculating grams of CO2 per deadweight nautical mile. The controversy here is that it assumes the vessel is always fully laden, which we all know is not true. There's some ports that have draft restrictions, so the vessel can't always be loaded up to her summer deadweight. However, it's a simple formula, and it encourages, supposed to encourage the more energy efficient planning of vessel operations. Then there's on the right-hand side, you have the energy efficiency operational indicator. This has been adopted by the EU under the EU MRV system, also adopted by the Sea Cargo Charter, which is the Charterers Initiative, and the Baltic Exchange have also adopted it in recent months. As I mentioned, it's similar to the annual efficiency ratio, but it considers actual cargo carried and only the distance that the vessel sails in laden condition. And it attempts to calculate the grams of carbon dioxide per ton nautical mile. The criticism to the EEOI system is that it penalizes high stowage cargo. So if I mentioned earlier that we have some vessels that are transporting wind turbines, which is supporting the energy transition. Now, wind turbines, they are huge. They take up a lot, volumetrically, they take up a lot of space on board. However, they don't weigh much. They're probably a fully laden handy-sized vessel, or even ultramax vessel, with windmill wind turbines and blades and towers might only weigh 5,000 tons. So 5,000 tons on a 38 to maybe 60,000 ton vessel creates a really, really terrible EEOI. So those vessels will essentially be penalized under the EEOI, even though they are contributing to or doing their bit to for the transition to renewables. However, vessels that are transporting low stowage cargoes like iron ore or metallurgical coal, they are awarded because they are typically reaching their summer deadweight. And this particular EEOI encourages ship owners and charterers to arrange their trades in such a way that the ballast leg is as short as possible in comparison to the laden leg. This is a snapshot of the Baltic Exchange EEOI. So you will most likely be familiar with the Baltic Exchange's standard routes, which ship owners typically benchmark against. So they have aligned their routes with the Energy Efficiency Operational Index and have established EEOIs in eco and full speed for all routes that they publish. So this is also something that owners and charters will be benchmarking against going forward. So what will this mean to our industry, all these new requirements in respect to sustainability, energy efficiency? So we have to ask ourselves, how will this impact the overall ship speeds? How will this impact the global supply of tonnage? How will it impact the existing and future period contracts? How will it impact our current and future contract of affreightments? How will it impact the tonnage charter parties and cargo charter parties? How will it impact the speed options when rating cargoes? And what will the situation be when racing for laycans, particularly in a strong market? Because there's a disincentive to speed up because you're going to be creating more emissions and negatively impacting your AER. However, ship owners will still want to reach the laycan. So it's going to create some challenging discussions between ship owners and charterers. Just so to let you all know, Oldendorff are looking into alternative fuels other than just biofuels. We have considered LNG, but you will notice no Oldendorff vessels are LNG powered. This is because, I mean, although we identify many advantages to running on LNG, such as, you know, it's a proven technology with supporting bunkering infrastructure that has already been developed and steadily expanding. So for the last 20-25 years, this LNG infrastructure has been built up. It's from a LNG, such as, you know, it's a proven technology with supporting bunkering infrastructure that has already been developed and steadily expanding. So for the last 20-25 years, this LNG infrastructure has been built up. It's from an emissions point of view, very low SOx emissions. NOx is reduced by about 95%, and there's virtually no particulate matter. It's not a marine pollutant, so in the event of a leak, it simply evaporates. And there's a clear visibility on the capital expenditure. So you'd pay between 20 and 30% premium for a new build if you went to a shipyard today. However, our biggest concern is methane escaping during the transport, transfer, and combustion of the LNG. So LNG has an 84 times higher global warming potential than carbon dioxide over a 20-year perspective. So for every 1 ton of methane that escapes during the in the value chain, it's equivalent to emitting 84 tons of carbon dioxide. And the regulators are starting to take note. And in fact, it's already been targeted under threat by the World Bank, NGOs, and even now, during the COP26 in Glasgow in November, there was a lot of criticism towards LNG. So it seems like regulators are doing a U-turn, a policy U-turn on LNG. So there is a significant risk of stranded assets if owners order LNG-powered vessels. There's no significant well-to-wake carbon dioxide emission reduction. So if IMO, and I predict IMO will eventually adopt life cycle assessment carbon factors, there will be not much well-to-wake CO2 emissions reduction. There's also a potential cargo loss due to the lower energy density. It has to be stored in cryogenic tanks at -162 degrees centigrade. And you would have noticed over the last few months, there's been significant volatility in the LNG price. It's gone straight through the roof in recent months. Ammonia has been talked about a lot in the shipping industry. The advantages to ammonia is that there's no SOx or particulate matter emissions and very low nitrous oxide emissions when using abatement technology. It's an efficient carbon-free energy carrier. It's the clearest path to complying or reaching the IMO's 2050 target under the current tank-to-wake regulations. So what's coming out of the stack, out of the funnel. However, the picture looks a lot different if the IMO adopt well-to-wake or life cycle assessment carbon factors. It's already produced and traded at scale. It's a long track record of safe handling, and Japan has an ammonia roadmap for power generation. So there is certain governments that are behind ammonia in their roadmap to decarbonization. The major engine manufacturers, WinGD, Wärtsilä, MAN, have roadmaps for the design and of an ammonia-powered engine. MAN has a 2-stroke engine planned. Earliest 2024, we can anticipate MAN to come out with a ammonia-powered engine, but it's not guaranteed it's going to be for the engine sizes that our vessels typically are equipped with. And it will still take maybe 2 to 3 years to build a ship. and not all shipyards will have the expertise to build an ammonia-powered vessel. Ammonia of the future will be most likely produced from electrolysis powered by renewables or maybe even nuclear. The disadvantages is that it's extremely toxic both as a liquid and a gas, so it requires prolonged IMO review for shipboard applications. Safety is of paramount importance for our company, so we certainly don't want to risk crew or port state control or stevedores, coming into contact with ammonia. It's extremely toxic. It has a low calorific value, so there's a cargo intake loss, but that's pretty much the same for methanol and also LNG. There's going to be some cargo intake loss because of the low energy content. As mentioned, the engine technology is still 3 or 4 years away. There's going to be storage complexities compared to diesel, so it's going to be extremely expensive to build ammonia barges, bunkering barges, and supporting infrastructure ashore. Although it's used widely as a fertilizer, it will mean that we'll have to compete with the agricultural industry for volumes and will therefore be prone to significant price fluctuations. It's currently not used as a marine fuel, so the supply chain infrastructure still needs to be developed, and we can see how long it took for the LNG infrastructure to be built. Low flammability, high ignition temperature, needs to be stored in cryogenic tanks like LNG, although not to such an extremely low temperature as LNG, only to minus 33 degrees centigrade, or pressurized tanks at 10 bar. Today, ammonia is mostly produced from hydrocarbons, so this confers almost no carbon abatement advantage and simply adds costs. So only green ammonia would offer, ammonia generated from feedstock of renewable energy and electrolysis. Methanol is we're seeing a lot of encouraging developments in with methanol. The advantages is that methanol combustion in an internal combustion engine reduces CO2 emissions by approximately 5 to 10% compared to fuel oil. In the future, blue and green methanol likely will become available, offering significantly lower emissions on a well-to-wake or LCA basis. So again, it will depend a lot on the direction IMO go in terms of adopting potentially life cycle assessment carbon factors for all the fuels. It's biodegradable, so in the event of an accidental spill, it is not considered a marine pollutant. It's relatively safe and simple fuel to integrate with existing storage and transport infrastructure, and already included in the IMO's IGF code. Compare that to ammonia, where IMO have not yet developed a code. And these codes can take many, many years to develop. Its application is suitable for both new builds and retrofits on certain engines. Marine use supply chain generally available through existing infrastructure. So it's available in about 140 ports globally. The disadvantage is that it competes with the chemical and plastics industry. So like ammonia competing with the agriculture industry, will also be prone to price fluctuations. It will also be competing with other modes of transport, like maybe aviation and trucking, who will also want to use it as a fuel. It has a wide explosion range. The engine roadmap for dry bulk fleet is undecided. It's got a low energy content similar to ammonia. So there's a possible cargo intake, although having said that, we've recently seen some designs of a Newcastle Max where there's been no cargo intake loss versus a traditionally built Newcastle Max that's designed to run on conventional fuels. So that's promising that the designers are using void spaces for methanol and ammonia in their designs. So more, if they can't get over that hurdle, then more frequent bunkering or increased bunker capacity will be required due to the lower energy density. The operational considerations for all these fuels will be safety, fuel availability, bunkering frequency, bunker storage, pilot fuel. So ammonia and methanol will still require a pilot fuel of about 5 to 10%. Initially, it will be low sulfur marine gas oil for that pilot fuel. Later on, it might be a second or third generation biofuel, but it's something that needs to be taken into consideration, is that there will be a pilot fuel required to create that ignition. Consecutive voyages versus tramp, the opportunity ships. So, you know, when you've got vessels dedicated to consecutive voyages on a COA, dedicated trade, it's much more easier to justify building a vessel to run on methanol or ammonia. However, vessels that are employed in the tramp trade need as much flexibility as possible. Yeah, investment strategy from a ship owner's point of view, we have to weigh out flexibility versus eco-optimization. Dual fuel issues, when to burn which fuels as prices diverge. We see this currently with the LNG dual fuel vessels. We don't have any, but we have been monitoring reports of owners that are running dual fuel engines on their ships. So it will depend a lot on the prevailing price of the different fuels. Crew competence and training. Crew will need to be trained to a much higher level to handle the complexities of these new fuels, and also port acceptance by port authorities, particularly when it comes to fuels like ammonia, which are potentially toxic. This is something interesting that Oldendorff have been looking into. So we fully acknowledge the advantages and efficiency gains that can be achieved through the use of wind assist technology, particularly Flettner rotors, and particularly on certain trades like North Atlantic routes. So we have signed a joint development project agreement with the Chinese ship design studio SDARI, Anemoy, which is a Flettner rotor manufacturer based in the UK, and Lloyd's Register, the classification society, to look into the technical and commercial feasibility of fitting these wind assist Flettner rotors on large bulk carriers of baby cape size, so 114,000 deadweight, to Newcastle Max with 208,000 deadweight size. And we are looking at different configurations. So this particular one shown here, this is a computer generated image. So this is not a vessel. This is a vessel that's at sea, but it's not fitted with Flettner rotors yet. But this is what it could look like in a seven rotor configuration. But one has to consider the what happens when you come into port. We can't have these Flettner rotors impeding cargo operations, particularly in ports where you've got gantry cranes that are not so high. So a folding design has been developed, and these aren't cheap. So this will need to be factored into the capex of a new building, or as on a retrofit. It has to be a decent return on investment. However, the production costs of these rotors will likely come down in the years ahead. And it's actually an old technology that was developed in the 1920s, but has come back 100 years later because of the decarbonization targets for the industry and the advancements in materials to build these rotors. So the demand is there, the regulatory framework is there to support the success of these devices. So these essentially harness the power of the wind, and it creates almost a lift that is converted into thrust. So the master can come off the throttle and still maintain the same speed, but with less fuel consumption and less emissions, or can go faster, but with the same consumption and emissions. And last but not least, we've also investigated air lubrication. So in ship resistance, the three main components are frictional resistance from form resistance and wave resistance. For low speed displacement vessels like bulk carriers and general cargo ships, frictional resistance is the dominant contributor and can reach 85% of the total resistance. So air lubrication is achieved by pumping air beneath the hull. In this particular image, it's showing one blower, but in reality, for a large bulk carrier, you'll probably have several of these blowers fitted. The bubbles, the air that's pumped beneath the hull reduces the area of the hull that comes in direct contact with the liquid flow, so the water, thereby reducing frictional resistance. However, we are a little bit skeptical about these systems being fitted on large bulk carriers because of the deep draft. So on a Newcastlemax, the vessels, when they're fully laden, are submerged 18 meters. So the back pressure, we believe, will completely net out any potential gains from these systems. However, maybe it's a possibility for the smaller vessels, the ultramaxes, handy size vessels, and maybe only if those vessels are sailing in ballast condition. And one thing else to mention is that the EU are currently looking to, in their proposals, to make shore-to-ship power supply, also known as cold ironing, available mandatory in all EU ports, and will be mandatory for, as the current proposals are drafted, mandatory for all container ships and cruise ships. However, it could be that they also decide to include bulk carriers and general cargo ships into this proposal. So looking at this proposal to equip one of our vessels, let's use a Newcastlemax as an example, for shore-to-ship power supply, we're looking almost at $1 million per ship. That's it from me. Thank you very much for your attention. I hope you could all hear me okay. And if you have any questions, I will try to answer them.
Thank you, Mr. Fee. As I can see, there are no questions right now. But if you can take, we can wait for a few minutes if our audience have some questions.
Sure.
So there have no questions, I think. I also think it's a very clear presentation. Mr. Fee, thank you for your presentation and sharing your valuable knowledge and time with us. We are very pleased to welcome you in this webinar event.
Thank you very much, sir. Thank you very much, everybody, for your time today. I hope the presentation illustrated to you all about Oldendorff and what we're about, and the progress we're making to align with the decarbonization targets set by the regulators, but also to go that extra mile and become more energy efficient than even required. So there's a good business case also to improve the energy efficiency and reduce emissions in our industry. And there's some really exciting things going on. There's a lot of challenges for our industry, but there's also a lot of opportunities there too. And if any of you have inquiries, I will send Professor Nuran my contact details and the general contact details of Oldendorff. We'd be glad to hear from you. So thank you very much once again for your time, and wish you a very good day.
Thank you. Thank you, Mr. Fee. Dear guests, the second session of the Marine Engine Technology 7 webinar series is ended. Thank you for your participation. Değerli konuklar, webinar serisinin bir sonraki oturumu 18 Mart 2022 Cuma günü gerçekleştirecek ve Sayın İlker Meşe tekrar bizlerle olacak. Karbon ayak izi nedir? Deniz taşımacılığı, EXI ve EEDI uygulamalarından nasıl etkilenecektir? Başlıklı sunumunu bizlerle paylaşacak. Kayıt yapan dinleyicilerimiz için toplantı bağlantı linki yine bugün olduğu gibi mail yoluyla ulaştırılacaktır. Kaçırmamamızı tavsiye eder. Sağlıklı günler dileriz.